You know, when we look at a massive skyscraper or a bridge, we think of strength, right? Permanence. But what if I told you its most dangerous moment, its point of greatest weakness, isn't 100 years from now in some big storm? What if it's actually before it's even finished? Yeah, let's dive into this kind of hidden danger in structural engineering. So, let me ask you, when is a building at its most vulnerable? Your first thought is probably, I don't know, 50, 100 years down the line, right? Battling earthquakes, hurricanes, just the wear and tear of time. But the actual answer is way more immediate. And honestly, it's a little bit unsettling. The real weak spot is during the messy, chaotic, and totally necessary process of its own construction. Okay, so this slide really breaks down the problem. See, on one hand, you've got what engineers design for, the final design load. That's the stuff you'd expect. People walking around, furniture, maybe some heavy snow or strong winds. It's all pretty predictable. But then there's the other world, the temporary construction load. And this is a whole different beast. We're talking about huge pallets of materials, heavy equipment, scaffolding. It's like the building is being asked to survive two completely different stress tests.
And that brings us right to the heart of the problem. You could call it the blueprint's blind spot. See, the design is all about the destination, the perfect finished building. But what gets missed sometimes is the journey to get there. It's like planning an amazing vacation, but completely forgetting to check if the car can actually make the road trip.
So the standard way of doing things is called final condition design. And look, on the surface, it makes total sense. Of course, you'd engineer a building to be safe for its final use. You want it to stand strong for a century, right? The whole point is to make it stable for its intended purpose. But here's the catch. That thinking focuses entirely on what happens after the construction crew packs up and goes home.
Which leads us to the super simple, almost obvious point that can get lost in all the complex calculations. A building, well, it doesn't just pop into existence overnight. It's not magic. It has to be built piece by painful piece, stage by stage.
And this quote from an engineering analysis just hits the nail on the head. It says, the design often focuses so much on that final condition that it actually creates a high risk of failure during the construction stages. In other words, in planning for the finish line, we can accidentally trip ourselves up right at the start.
Okay, so let's get specific. Let's pull back the curtain on this unseen weight and really look at the hazards that are hiding out in that blueprint's blind spot.
So what exactly are these temporary construction loads? Well, think about it. We're talking about massive, concentrated weight. Picture it. Huge stacks of steel beams, pallets of concrete blocks, piles of drywall, all sitting on a single floor that isn't even finished. Now throw in heavy machinery, scaffolding, and maybe a crane lift. All of that puts an enormous amount of pressure on tiny spots. It's all happening on a structure that's basically just a skeleton at this point.
And this chart, wow, this really puts it into perspective. Look at this. A floor slab might be designed for a final load of, say, 50 units. That's your people and furniture. But during construction, with all that gear piled up, that same slab could be hit with a temporary load of 120 units. That's more than double what it was ever supposed to handle in its entire life.
So you've got these huge, often unplanned overloads, stressing out a structure that doesn't even have all its walls or supports up yet. It's like asking a newborn to lift weights. You're demanding the most from it when it is, by definition, at its absolute weakest.
Okay, I know this all sounds pretty alarming, but don't worry, there's a solution. And it's not about magic, it's about a shift in thinking. It's about creating a new way to look at structural safety, one that's all about designing for the journey, not just the destination.
And the fix here isn't just, add more concrete or use thicker steel. That's the brute force way, and it's super expensive and inefficient. The real answer is way more elegant. It's simply a change in perspective.
So what does this path to safer construction actually look like? Well, it's a pretty straightforward three-step process. First, you have to analyze the construction in stages. Treat every single phase, from the foundation to the topping out, as its own unique engineering puzzle. Second, you quantify those temporary loads. No more estimating. You calculate the actual weight of materials and equipment. And finally, step 3, you integrate all that info right into the main design from the very beginning. That way, you know the structure can handle the stress at every single step of the way.
When you boil it all down, it comes to this. The job of the engineer isn't over when they hand off the blueprints for a safe, finished building. Their responsibility has to cover the entire process of getting there, ensuring the whole journey is as safe as the destination.
So the next time you look up at a gleaming new skyscraper, think about this. Yeah, the finished building is a monument to design, for sure. But maybe
just maybe, the real, overlooked feat of engineering isn't the shiny thing you see at the end. Maybe it's the incredible, complex, and sometimes dangerous journey of actually putting it all together safely.